In this simulator, we can see an electrical conductor in the form of an aluminum can with overlapping positive and negative charges. Right now, we're seeing only the blue negatively charged electrons. Underneath those, sometimes you can see some red positive charges poking out. So this can currently is electrically neutral. It has no net charge. But let's watch what happens when I bring in a charged object in the form of a glass rod, which is going to have a positive charge on it. What you saw is that some of those electrons very quickly moved from the bottom, far from the positive charge, up to the top of the can, closer to the positive charge. And as a result, this electrical conductor has a net polarization. The negative charges are closer to the top, whereas the positive charges are closer to the bottom. And this is going to cancel out the electric field so that if I look at, say, those positive and negative charges in the middle of the can, they're not moving. So they're feeling no net electric field because the electric field from the negatively charged electrons on the top and the positively charged protons on the bottom are canceling out that external field from that glass rod. If I remove the glass rod, you'll see all those charges go back and that polarization disappears. And alternatively, I could bring in a rubber rod, which is going to have some negative charges on it. So think for a minute about what will happen if I add a bunch of negative charges to the top right-hand corner of the simulator here, pause the video, figure out what that's going to look like, and then resume. Okay, I'm assuming that you've paused at this point, so let's check if you were right. So I'll bring in that rubber rod with some negative charges on it. You'll notice that I get some polarization again. So I end up with my positive charges closer to the top of my aluminum can. So I have a net positive charge on top, a net negative charge on the bottom because some of those electrons have moved around again. I'll still end up with a net zero electric field in the middle. So those central electrons are sticking with their protons. They're no longer moving around. And you may also have noticed that the can moved a little bit because when I induce polarization in a net neutral object, the polarization itself means that there's a little bit of a force on the object. So if I bring in that glass rod again, we see that can move a little bit under that net electric force that's induced by the polarization within the can.